Yeah, so I start recording. Let me share my screen. So I'm sharing the full screen, guys.
Yeah, I can see it.
Yeah, I can see it too.
Perfect. So today we are going to discuss the assignment 2 solution. I think that it will be nice to discuss it here, that most of the people that are going to watch the video later, they can benefit from the solution and the discussion that we are going to do it now. Again, I want to thank you, Jason and Kirsten, for being here, because being here in this optional attendance make an interactive environment that all of us will benefit from it. And yeah, Jason, do you remember when we were in the Monday in the university? I shared with you a message from one of the students.
Yeah, I saw that.
Yeah. So maybe we can share. We can also, this one of the student was he already finished with me a course, object-oriented programming in fall 2000, the last fall, and I showed the message in the other class that even though it was an OLO course, it seems that this student was following the course. And since he was following the course, even though I don't know him because he was not attending the live session, but he sent me a LinkedIn message telling me that I am your former student. The material of the course, it was very helpful, and it helped him in his job interviews. This is what he has already sent me an email at LinkedIn. It was a nice message from him, but I also feel happy to him that he has already starting a new job that he has that he wants to start. And it seems that even though people who will not attend here, still they can benefit from following up the course material. Especially when we're doing our best to have many examples to understand more the concept behind the course or the course material that we are discussing here. Okay, so let's start with the assignment 2 review. The assignment was a 3-part. The first part about multiple choice question. Do you remember these questions?
Yep.
So one applied to instance variable, the visibility modifier in false encapsulation. So which one of the modifiers this is in false encapsulation, and give a good example about encapsulation? Static, final, public, private. Hi, Kua. Go ahead.
Hi guys, hello Prof.
Hello.
Hey.
So
I said private. I said D.
Yeah, same
You
here.
said private. What about you, Kura? How are you?
I'm good.
Kura, we are discussing the solution of assignment 2 before we publish the grades. And then we have a small part to discuss it today before we make a nice group work exercise. So we start with the assignment 2 questions. So the first multiple choice was talk about which modifier. We know that we have a protected, private, public, and the static, normal static, we use it also. There are special use of the static. Maybe later there was a question about it. So which one will enforce encapsulation? Kirsten and Jason said private. Do you agree with them? Maybe they are incorrect.
Yeah, I think they're correct.
Really? It was your solution, private?
I can check it.
No, you know that. Yes, it is a private. Yes. Why private? Because when we talk about encapsulation, it means that there are some parameters and variables. We are going to make an access control for them, and the accessibility of this one will not be done without any control. There is a control for that, there's a control for accessibility. And so only the object of a special class can use this private within the scope of the class. When we have to go to the private JSON, there is also, so what will be the next step to access a private?
Get and
how do I make a get on public post? Yes.
Yeah.
Perfect. So let's now go to the second one. Methods that can be called directly through the class name and don't need to have an object initiated or called. So method directly through the class name and don't have an object, which is we don't have to create an object in order to call this method. So which type of method these methods should be to do this? Carson.
I said C.
So static.
Yes.
Jason?
Agree.
Probably or sure?
Yeah.
Probably or sure. Cora?
I just follow their answer.
So what is the answer? Static or you don't have an answer now? Cora, I asked you, do you have an answer or you don't have an answer?
I can check my answer because I'm just
No
using
worry,
my phone.
forget about it. No, forget about it. We don't want to waste time on this, but just maybe we are making this argument or this discussion not only to have the answer and also to understand more why we need this answer. So the question said that we can use the method of this class without creating an object from this class. So suppose we have a class A and there is a method X we have already defined in A. So if you want to use X, we can use X directly without creating an object from A. Normally, according to the OOP concept, if you want to call a method, you are going to create an object from the same type, from the same method class where you have already defined your method. However, there is exception for this and special case when it is static. So a static one means then we can call this without having without creating an object and calling this method via this object. So a static, yes, correct your answer. So now is the original class that is used to derive a new class using inheritance is called. So I think so it is too easy. Just talk about the abbreviation. So the question is, the original class that is used to derive a new class using inheritance is called superclass, parent class, base class, all the above, neither A, B, nor C. What do you think? So the class that we use it to derive another class, which means that this is a class A, we create another class derived from A, B. So what is the name of A in this case?
All of the above.
All the above. Thank you so much, Cora. Yeah. So it can be superclass, parent class, base class. Yes. Okay. Now, overloading, overriding, overwhelming, substituting occurs when a child class defines a method with the same signature as the method in the parent class. So, is it overloading, overriding, overwhelming, substituting, or a child cannot define a method with the same signature as a parent? I think this is incorrect, but has nothing to do with it here. So, sorry. If you go to A, B, C, D, is it A, B, C, D? I think so. C and D it is not an abbreviation overwhelming. So it is not a technical abbreviation in Java, but however about overloading and overriding maybe. So is it overriding or overloading when a child class define a method with the same signature as a method in the parent class? Same signature. Is it overloading or overriding?
If it's the
So
same
we have
signature, then
yeah.
it cannot be overloading because
Perfect.
yeah, it
Yes.
would have to have it could have the same name, but it would have to have different parameters. So it has to be overriding.
Perfect. So overriding, then we just keep the same signature. When we talk about signature, we talk about the name and the parameter. So we will keep the name and the parameter the same. We just change the behavior of the method. And in this case, we name it overriding, not overloading. Yes. I think we have 5. So the last one is in order for derived class, so derived, we have inheritance, to have access to encapsulated data members and method of the superclass. So we have a superclass, we have a child class. The data members and the method should be declared using. So we say we're talking about the data members of the superclass. And so we have a method and variables defined in the superclass. And in order that this child class can access these data member, again, parameters and methods. So we are going to declare them private, public, protected, final, static.
My answer was C.
C. So again, should not be final and static. Because when we talk about a class is a final class, and we cannot make any further inheritance. Static, which means that we can use them, however, we can change the value of this. And when we talk about, so we have choices public, private, protected. So if you go to the public, it works. So public can be, however, we are talking, and so if you go to the private, so we can't use them. We can't, because it will be only for this class. So we have now public and protected. Both can work, public can work for all. But when we talk about encapsulation, because we are talking about encapsulation, which means that we should protect these data members that can be accessed within the inheritance hierarchy, not out of this. So in this case, we have to do it protected. Because as I said, we have to access encapsulated data. In order to have this encapsulation, so we need in this case to have a protected one. However, as I said, public work, because public work for all. However, the protected one will keep the privacy and the access control within only the inheritance, not for the whole public classes in this case. So if I can say public and protected can work, but protected is the best to use it when we talk about encapsulated data in this case. Now I think we have the encapsulation here. So before we go to this encapsulation, anyone? Jason will give me the answer. So when we talk about encapsulation, can you define it in simple word? What is encapsulation, based on your understanding so far?
It's like limit some others to not to access something.
Yeah, we have already, but this is encapsulation is somehow make yes, it can make some privacy, internal privacy.
Yep.
Which means that we are a family here. So being a family, we can share our data, but people outside our family can't share this data.
Yep.
So which means that within the inheritance group, we can share our data, but out of this, we cannot share our data. So we preserve our privacy and make ourselves governing, if we can say it like this. And okay, there is another part from the question, how we can enforce this in Java, how we can do this?
Just like declaring it as a private or protected?
Yes, we declare it as a private, and then we can make get post method as a public, and later we can call this method to access this variable in this case. Yes. Thank you so much. This is what we have already, encapsulation technique which hides sensitive data from the user. So we can enforce by declaring class attribute and method as private. A method as a private, and the public get methods are implemented in this case. Okay, so now the next question is, you are asked to give an example about static variable. So static variable, it is a variable that the value of this variable, it is unchangeable. So you are not going to change it in the, whenever you have inheritance, it is a static value, cannot be changed in this case. So anyone know about this example and where we can use it?
I thought static variables meant that it's just accessible without having to create an object. Is that not what a static variable is, or?
Yes, but why we have to do them? Why we need them?
Oh, okay, I see. Well, for me, I said they're used so that you have a number if it's commonly used, or if this variable is commonly used in a program, and you don't want to have to create a class to use it, you'd use a static prefix. I think that's what I said. I can't remember exactly though.
Wait. So can you repeat it? So you said that if you don't want that the members from the child classes to edit the values, then you can use it. This is what you want to say? Was it what you want to say?
Sorry, that's what I meant to say.
Okay, but even though can okay, but this doesn't give us a clear image when we have to do it. What? Okay, let's ask the question in another way. So why we want to prevent or stop or prevent the child classes from changing the value? Why we need to do this? Why?
Well, if you have a let me think about that.
Because there are, let me help you on this, because there are some values, they are fixed value and should not be changed, because especially we can see this when we talk about mathematical fixed value, like the pi value.
Oh yeah, yeah, my bad.
So this pi value, for example, it is unchangeable one. Why it should be changed? And if it is changed, this will affect other calculations that will take place during my program. So, and in this case, rather than creating this value in an object, and then whenever we want to create a new object, we are going to create it with S. Because if you remember, when we talked about the object and the classes concept, we said when you create an object, it will inherit all parameters from the class, and then you can assign new values. So if you have a parameter x and y and z in the class, and then you create object A, so A will have x, y, and z. Then you create object B, B will have x, y, and z. And then you create C, C will have x, y, and z. So now from let's say from memory point of view, you are but you need it. You need to have 3 different variables, and you need to have 3 instances from these variables, which is 1 instance per an object, because you suppose that each object will have different value. However, if this value is unchangeable, and then you create for each object a variable which is a static one, suppose this. In this case, you are duplication. You make a duplication because you are losing part of your memory, and it is inefficient to do it like this because this value will not be changed per object. Why you have to create it per object, and you don't want it to be changed per object later. So let's make it static since the value is unchangeable and we need it for further calculation like the pi one in this case. Let's go to the 3rd question. So method overloading, we have already talked about method overloading and overriding, required that a method have different signature. I think we have already discussed this carefully, yes? What part of a method are used in the signature?
It would be the name and the parameters, right? Is that what you're talking about?
Yeah, so the part which means
for overloading though.
Yeah, overloading requires that the method have different signatures. This is what you have already said.
Yeah, but it would have the same name, but have different parameters. Okay.
Yeah, it should have the same name because it has different name. It's not anymore the same method.
Yeah.
So when we talk about overloading, then they have different signatures.
Yeah.
So the signature. So what do you mean by signature? Can you tell me what we mean by signature?
Well, to my understanding, the signature is the name plus the parameters.
Yes, perfect. In this case, when we have an overloading, we'll have different signatures. However, when we have overriding, we will have the same signature but different behavior or implementation.
Yeah.
So yes, method overloading can when a child class declare a method that has the same name as the inheritance but different parameter and thus different signature. So the signature for method include method name and its parameters in this case. Okay. So if we change the parameter, we change the signature. So I think this is the last one, should be 5.5. Yeah, no, still there's another one. Compare and contrast the private visibility modifier to the protected visibility modifier. Which is the protected visibility modifier as a better choice in that? I think this is also, we have already discussed it now. So the question is about comparing private to the protected, and why protected is a better choice in inheritance hierarchy. So can anyone help me in defining or describing the difference between protected and private? What about you, Jason?
I know what is the difference between those two, but like I don't know what would be the good example.
Okay, can you just let's first define what is the main difference. So if we go to the private,
yeah.
Okay, so that the private one, which means if I declare a parameter as a private, what does this mean?
That parameter is only accessible in that specific class only.
Perfect. Which is okay. What about now the protected one?
It can be accessed in that class and each child class.
Perfect. Both of them talk about encapsulation because both of them they make a control for the access. So concerning encapsulation part, but one make encapsulation, which means that only for this class, and somehow for the other one we make encapsulation, apply the enforce encapsulation for the family in this case. Okay, perfect. So why the protected is better choice in inheritance hierarchy? You have already said it, by the way. Just to rephrase it because I will help you. So when we will go to the, if we will have a subclasses,
Yeah.
normally when we will have a subclasses, we have inheritance. This means that the child class, it's going to inherit all variables for further usage later, and maybe include more variables from the child class based on the existing variable from the parent class. So now the question was that, okay, so if I will make it a private, and then I will have a trouble about accessing these variables after the inheritance. So if I'm going to make inheritance, it then means this is a child, and normally it should have an access if for all parameters for the parent class. So in this case, protected is better because it's more, it fits more when we talk about inheritance more than a private, because having private and with inheritance, we need to manage this in this ways, because now these parameters, it cannot be accessible even though by the child class, and we should aware about this. But however, when we make inheritance, we expect that all the parent class, parent members are accessible. So both, as I said, enforce encapsulation. So in this case, if you expect there is no inheritance for this parameter, or even though there is inheritance, but however, we need to make a privacy for them. We go to the private variables. Again, the private variables, we will not go them with their inheritance, but we can do it. We will go to the protected one because it's enforcing encapsulation within the family one. And most of the time, this is what we needed. Okay, so this is about protected. This is what we have already said. The last one before we will go to the solution of Kerson today. Our new colleague Kerson will be a professor, university professor later. So today he will make a try how he can present a solution for the student. It will give him a good experience. What do you think, Kerson?
I guess I'm up for the task.
So let's go to the last question before we go to the implementation part. Suppose we create a subclass or a class that has a method called some method. If we will override some method in the subclass, is it possible to access subclass? If so, how? So the question said if we have, yes, it is possible. This is here. The question said, suppose that we have a subclass from a class, which we have inheritance. Class A parent, class B is the child one. And we have already made an overridden. Again, we have already discussed overridden. We will keep the same signature. We just change the behavior. Is it possible to access superclass version of the same method? If so, yes. Because if you will have a class A and a class B, B is a child for A, and here we have already defined a method, we name it X. So B will inherit this version. It will have the same X, and B also can make an overridden. So it will take X, for example, this here, X return 1, suppose. So it will inherit that X return 1. And also we can have another version from this that return also 2. So here, do you know, guys, this is a good question, by the way. So as I said, we have a class A, class B. There is here an X return 1, sorry. And here we have, so B will inherit X that return 1. Then B make an overridden for X that will return 2. So if I will now in B, can I access the old version and the new version at the same time? Yes. How? You got my question?
Wait, at the same time?
Not at the same time, which means that I in B, in B class, can I access the two versions?
Yeah, you can.
Yeah.
How?
you use the super keyword to access the older version.
Yes, perfect. Kura, go ahead, Kura. Do you want to add something? Kura?
No, sir.
So you want to, you have the same answer, which is a super one?
Yes, and when creating the new object, you will use like the error we encountered last time. We use this to point.
Yeah, this to
Variable.
point to this one, yes, yes. To the variable to the latest version, or you use the super one to point to the old version in this case. Yes. So the super key can be used here in B to tell the compiler that that the super version which is needed here. Perfect. Before I go to the Java recursion, which is another new part we want to discuss. It's a very small one, but it is nice to discuss here. So, Kirsten, can I ask you to show us the implementation part that you have already done?
Yeah, for sure. I just need to pull it up real quick. I need to find it.
Okay.
Summary
I
number
will
2.
stop sharing from my side.
Assignment number 2. Okay. I forgot how big this thing was. It's actually probably not that big compared to other stuff, but
Yeah,
okay,
stop it. Yeah,
I'm gonna start sharing it now.
yeah, go ahead. Thank you.
Okay, can you see it?
Yeah, and it would be better if you can also zoom it a little bit.
I can try. I don't know how to do that though.
You alt and with a with a mouse scroller.
Oh, like that. Okay.
Yeah.
All right, I'm gonna start at the bottom because this is kind of just the implementation of the stuff at the bottom.
Yeah. So I think before we go to the main method, go to the other classes, or you put all of them in the same file. Yeah.
Yeah, I put all of them in the same file.
Yeah, according to our hierarchy, I think so. The first one is the shape or the point.
Yeah, I kind of just did it
The
this way.
shape. The shape, yeah.
Yeah, so I'm gonna start the shape here.
Yeah,
So
go
I
ahead.
just created a interface shape. So it's just only gonna have abstract methods. So every single class that inherits this or implements this is going to have these methods, and they're going to have to override them because they don't have any definition by themselves. So I just made 3 public abstract methods: get area, get volume, and get name. And because we're going to have different classes, they're going to need to implement them differently because they're different shapes. So their area formulas and volume formulas are going to be different. So then I go to class point here and make a class called point. I'm implementing this shape interface. I give it 2 private double variables called x and y for its position in the Cartesian plane. We have the first, because they're private, I'm trying to create encapsulation for this class. So I'm going to have to make get and set methods for both of these. So I made them public. So the first one, because this is a double, this has to be a double as well. So I just said get x, and so it's going to return the x position. And then the same for y, and then the set x is pretty straightforward. You basically just get to set this x variable whatever you want. So it's going to have a parameter of a double, and then I'm just saying this dot x equals input. I used this dot x because we have inheritance, so I didn't want to get the compiler confused around about which x I'm going to be talking about, because this class is actually going to end up being a super class for another class. So that class is going to also have an x. I didn't want the compiler getting confused which x to use, so I just used this dot x. Same for this dot y. And then here I started to override these methods. So the first one is get area, and a point doesn't have area, so I just decided to say return 0. And get volume, same thing. Point doesn't have a volume, so I just said return 0. And then the override for the get name, I just said to return point because that's what the class name is. So this circle, it's going to extend this point. So it's going to basically inherit everything from this class, which in turn inherits everything from this class. So this class will also inherit everything from the interface. So I'm going down here. I added a private double called R for the radius, because circle has radius, but it also has a position in the Cartesian plane. So it inherits the X and Y, these public doubles. So I'm going to have to override the public methods here because it actually does have an area this time. So here I just said return pi r squared. So that's its area. And here I didn't actually override get volume because the volume of a circle is equal to 0. So I just let that be. So I just kept that the same. And then secondly, I overrid the get name because here it's point, but I want it to be circle. So I just created a circle. And then because this is a private double, I needed basically the same thing I did for the X and Y. I just made a get and set methods for the radius. And I don't need to make any get and set methods for its X and Y position because it already has that from this class and inherited from that class. So now I'm going down to class cylinder, which extends the circle. So it basically inherits everything from the circle. So it's a pretty big inheritance, as you can see it, from shape to point, and then from point to circle, and then from circle to cylinder. So here it's basically going to inherit every single one of those attributes and the methods. So I'm going to have to do a couple of overriding here. So I just made a new private double named R1. Oh, actually, I never used this, so I don't need this. Just get rid of that. All right, so
don't worry, it will not affect your grade.
Okay. So I didn't actually need an R1 because it already inherited this double radius. And so I need to make a new double variable I just called it H1. I could call it H, but it doesn't really matter. So this is the height of the cylinder. That's what this variable represents. And because it's private, I'm going to have to do the exact same thing I did for these, like for the radius and for the X and Y coordinates, just a public get and set methods. So I overrid, first of all, the area because the area of a cylinder is different from the area of a circle. So I use this dot get h. Yeah, it's basically just the area of a cylinder right here. I made it return this. So it's just the area of a cylinder. Then the next thing was get volume. I had to override that because here in the circle, here in the point, I defined it as 0, but it's not 0 because it has volume. So I just say it was pi r squared times get h, or times h. And I used this dot get r because it has to use the current radius.
Okay.
Yeah, the current radius that we're talking about. We're talking about the cylinder. It has to use the radius of the cylinder, not the.
This is what Cora said, that since we need to point to the compiler that use a version method of this class in this case.
Yeah, so that's what I was running into some troubles when I was trying to troubleshoot this.
Okay.
That I was using the get r, but I didn't realize that I needed to say this dot get r because I was getting confused about which r radius I was referring to. So that's just the volume. This is the area. This is the volume. Right here, just get name. So it's cylinder instead of circle. And yeah, that's it for the classes.
Mm-hmm.
Now we're gonna go up. Now we can go back up to here.
Yeah.
So first thing I do is, because the prompt said that the user can make as many of these classes or of these objects as we want. So I just made array lists, and they're basically just going to be of type. Oh no, never mind. They're just array lists of type point, circle, and cylinder. So I made them of, like, the type is of the classes that they're holding, or they're going to hold. So I have 3 array lists, 1 for point, 1 for circle, 1 for cylinder. Then I started scanning, or I just said my object, and this is for scanning basically an input from the user. And I sent out a prompt of how many point objects that the user wanted to make, and then I made an integer called pnum, and that's going to basically hold the user input. So that's what this is. This pnum is equal to myObject.next int. This is basically just inputting the user input, or like storing the user input. And I did the exact same thing for the circle. I made an integer called cnum, and then the same thing for the cylinder. So cylinder num, that's the same for that. And then I basically, what I did here is we need to set the attributes, or basically the parameters of each point that the user inputted, or that the user wants to make. So say you have 5 points, and so this pnum is going to equal 5. So this is going to go through 5 times to set the attributes of each object that's going to be made. So this is what this is. So it's going to start at 1, so it's going to make a new point, and then this is basically going to go through 5 times, and it's going to make 5 times, or like pnum times, and this is going to make pnum points, if that makes sense. And then here the user input is x and y coordinates, because that's the only parameters, or the only attributes that are in points in the point class. And then I just said plus enter x and y coordinates for points counter. So this counter is going to start at 0. So it's going to say enter x and y coordinates for point 0, and then all the way up to point pnum, whatever pnum is. And then you're just going to set these the x and y variables. And this is basically going to this right here is going to make a user input. And so you're going to take 2 user inputs. And then you're going to add this new point that has these attributes that the user has set, and you're going to add it to the point array. And that's what I'm doing here. And then that's basically it for the point or the point objects. And this is basically the exact same thing I'm going to be doing for these 2 for loops. Except that for the circle class, it's going to have more attributes that you need to set. So it's going to have, on top of these x and y attributes that it inherited, it's also going to have a radius that you need to set. So that's basically what I said here. Enter x and y coordinates and radius, and the system, or the mechanism is going to basically be the exact same as this for loop. So it's going to create a new circle. You're going to set the attributes of this current circle, and then it's going to add that circle to the circle array. And I did basically the exact same thing for the cylinder, but it's basically just going to be cylinder, so it has 1 extra variable right here, so height. So yeah, like I said, same mechanism as these 2. You're going to create it, enter the...
Yeah, it is the same mechanism as you already said. Yeah, thank you so much, Kirsten. Well done. Perfect. Yeah, I think so. We are done with this.
Yeah, basically, and then I'm just going to go through the arrays and then print out for each one the stuff that you entered. So that's it. Sorry if I was a little too slow, but
no, you are not too slow. I told you will be a good professor. You will be a colleague for me.
Thank you. I appreciate it.
No,
All
you
right,
did
stop
do
sharing.
it in a very, you presented in a way that all of us can understand it. I'm talking about myself. Maybe we get now a feedback from Jason and Kura about it, about your
Yeah.
presentation, Skid. Jason, do you have a question?
Yes. Yes.
Yes.
Person,
You want to
how,
ask you, Jason? Go ahead.
yeah. How did you like create the array for the object?
Oh yeah. I'll share one more
Jason,
time just to show you.
yeah, sure, yeah. Share it for.
So how did I create the array list?
Yeah, cause like for me, I have hard time to have a like array list with different type of data, like cause we need to save name and some numbers together in the array list. So
Yeah. So what I did instead of making array lists of variable types, I made array lists of class or like object types. So each array
okay.
list will store classes. So this is what
Mhm.
this is. Usually you'd put in integer or like string, say here,
Yeah,
but
yeah.
instead of putting some sort of variable type, I just put the type of class. So I put in
I
point,
see.
so it actually stores in. I didn't know you could do, like, I was looking around on the internet to find if you could do that because I had the
Right.
idea. I was like, can you actually do that? But yeah, so
Yeah.
I found out that you can actually do that. So that was really helpful. That's how I did
Good,
it.
good.
Yeah, this is when we have already discussed about array list. We said that normally array list it is a list of objects. So even though you are going to put string, you will use that array list of string. So it is not the same concept like the array. The array, you declare an integer array, and then for you are going to put different integer values. When we talk about the array list, we talk more about list of an object. Even though string values, they will be a string object in this case. You got it, Jason?
Yeah. It really helpful.
Yeah, sure. I told you Kirsten will be our the next professor. Kura, do you have a question for Kirsten today about his solution? If Kura, are you still here?
Yes, Prof. I don't have any question.
You have a similar solution to him,
No, no, I have different
but the same mechanism?
solution. Yeah, but I think
Okay.
my solution is the logic is simple, not like that because I don't use the point class.
Yeah, but according to the question, don't worry about the grade again. According to the question, we should use a pointer class.
Yeah, I think I have different output.
Okay, no worry. Okay, if you don't have any questions, so all good. Thank you so much for about this. Kirsten, again, thank you so much. I like your
Yeah,
solution. Your solution was based on what we have already discussed in the class. And the aim from this example was how we can use inheritance, how we can use interface, how we can use encapsulation, polymorphism, all the different topics that we have already discussed. You can see it in this example. Okay, let's continue. There's a small part still, and then a very small part I want to share it with you today. Let me share my screen again. Sorry. You should be able to see my full screen, yeah?
Yep.
Yep. So I don't know if you are familiar with this, maybe another programming language, Recursive. Are you familiar with this?
I have heard of it, yes.
So do you have any knowledge about it, this concept?
Yeah, I mean, it's a little, I haven't used it in quite a while because I was struggling with working through the examples, but it's like a some sort of mechanism or a function that calls itself in the definition of the function?
Yes, so it is a function that's calling him itself. Yes, 100%. This is correct. So recursion is, as Kirsten has already said, so it is a process which is a method calls itself. This method that is calling itself, we can name it as a recursive method because it's calling itself recursively. And using recursive method, it's make less compact, which means that you will have a less number of lines, but sometimes it's not easy to understand. Sure, you can understand it, but the positive point, the main advantage of using recursive is that we will have a compact, which means have you less number of code. Whenever we have different calculation or different processing related to each other recursively. So we will have a method. We will have a method, and then this method is going to call itself within the implementation of the method. Let's take this example. The first example, we can see it is a simple one. Suppose we want to add two numbers together. It's easy to do it, but if we have a range of numbers, which means that I have a range number from 1 to 100, for example. So here I can use here the recursive one. So let's suppose in this case I will create a class, version test, and then I will define a method in this class. You see this method will take, which is the range of the number. So if according to this one, I give it from 0 till this number, from 0 till A. So I will go ahead and make if A is greater than 0, because it should have a stop condition. I will make A plus, I will call again the method for A minus 1, which means that 10, 10 minus 9, then I will go to 9, 8, and then the value I save it here, this temporary variable. The next iteration, what will happen, that again I will call the method again, it will call itself, and then this method will call itself again. So based on this iteration, each iteration we will have a recalling for the method itself. And then sure, I will create an object from this method, and then I call this method and pass the parameter. If you are going to track it, how it works. So 5 plus calling this method. Calling this method will go here and call another one. And then this is, we will call another one. And then this will call this, and this will call this, till we reach a stop sign. And then summation, all this output will give us 15 in this case, which is the expected result. This is recursion. As I said, it will make a compact code, which is more efficient. Again, more efficient. However, sometimes it's not easy to trace and track how it works. When we talk about a more complex examples, again, it will be more efficient by making different loops directly without calling the method or recursively calling the method itself in this case. So we should take care about infinite recursion, because sometimes if we will, it is the same like a loop. There is no stop for the loop. You will have an infinite loop. So you should, whenever you think about recursive function, you should think about halting condition, stopping when it will be stopped. Like here, for example, since I am supposed to take A, it will stop till from 0 to A. This is why this condition, I have this condition here, where I will stop calling myself a method. So it is a must to have a halting condition in order to avoid infinite recursion here. Okay, so let's take this another example. This another example is factorial. So all of us know about factorial. So we can make the factorial using recursion method. Again, you can do it another way, but it will not have, it will be more, it will not have the same efficiency when we talk about recursion. Recursion, it is the most efficient to use it whenever we have recursive iterative function, iterative calculation, and in each iteration we do the same calculation but with different input, which is the next value or the next value in the range. So if I'm doing the same calculation but with different values, the best to do it is using a recursive one. It will be more efficient, less complex comparing to other way we can do it. So factorial, all of us know about the factorial. When we go to 5 factorial, we start 5 times 4 times 3 times 2 times 1. So since factorial 5, sorry, what's that? For factorial 5, it is 5 times 4 factorial, and 4 factorial it is 4 times 3 factorial, and 3 factorial equals 3 times 2 factorial. 2 factorial equals 2 times 1 factorial, and 1 factorial is 1. So when we talk about factorial, we are doing the same process many times, which is multiplying a value with another sequence of values. So in this way, the best is to do it recursive one or recursion one. So here I create a class I name it factorial. I create this method that will call it. So I will make here if n less than 1, it will return 1. Else, it will call itself. As I said, in this case, when like the same here, we are not using the loop here. We're just using a condition and calling ourselves. And this will stop whenever the halt condition will be satisfied. Here in the main method, since I want to print out the whole value for 1, 2, 3, 4, 5, which is the output here, in the main method I have to create different variables, and A, B, C, D, E, 5, which is the number that I will search with a factorial for them. And then I will run the function for each number, and then I will print the factorial for each one. I should get this result, which is the same result, expected result from here. No loop, just calling myself as a function. Whenever there is an iterative operation, the same operation will done iteratively. So no need to make the loop, just call myself, and I should be aware about where to stop in order not to have infinite one. I think we can try a simple example. It's too easy. It's the same like the factorial about Fibonacci. You know about this? Are you aware about it? Math, how we can do this?
Yeah,
Yes,
it was used to find like the bunny population, wasn't it, or something like that? I remember.
Yeah, so if you can for the first plot, then we can say the 0, 1, 1, 2, 3, 5, 8, 21, 34.
Oh, like what is it? Oh, it's yeah. So it's the first or it's
Yeah,
the
but you know
previous.
how we can calculate it? How we can calculate this? You know how we can do it?
Yeah, so you make well, it's a sequence. So you say T1 is equal to 0, T2 is equal to 1, and then T of n is equal to T of n minus 1 plus T of n minus 2. If that makes sense, because yeah.
That makes sense. Yeah. So can we do it? This is a group work like always. I'm collecting the bonus for you. Don't worry about it. You'll have a more bonus. Maybe it will also affect your project grades for this case. You will get a full grade in this case since you will have so much bonus. So what about doing this as a group work by applying recursion for having the output for Fibonacci in this case? Are you okay to do it now?
I mean, we can try it, I guess.
Yeah, sure.
Yep.
Okay, so like always, you will go to the room and then we will be back here. I will stop sharing and then I will create a room. This is the old one that needs deleted. I will create another row, just one. Okay, let me open the one. I'll stop recording also.